Good morning. Suppose we have to calculate, we have a circuit like this and we have to calculate EI8, current in this branch. Well, it looks complicated, but we can do it by using the current divider. I will show you how to do it. First of all, you have to use the current divider. If you remember, if you have to calculate I1 and I2 in function of the main current, remember that if we have voltage here, the main current is equal to V over the equivalent resistance of this circuit, so it means it's V divided by R1 times R2 over R1 plus R2. So it means that V is equal to R1 times R2 over R1 plus R2 times main current. Remember that I1 is equal to V over R1. If we replace V by this expression, it means that I1 is equal to R2 over the sum of the two resistors times main current. Same thing for I2 is equal to R1 over R1 plus R2 times the main current. And we are going to use these to solve E8. Okay, here we have to calculate I1 so that we can calculate I3 and I2. We need I3 to calculate I5 and I4, to calculate I7 and I8. We need to know the value of I5. Okay, let's start. Let's calculate our equivalent to calculate I1. So these are in series, R7 plus R8 plus R9. This is first step. Later they're in parallel with the R6, second step. Later they're in series with R5 and R10. This is third step. And later we have in parallel with R4. This is fourth step. And later we add R3 and R11. This is fifth step. And now they are in parallel with R2, sixth step. And the last step is we add R1 and R12, and this is the equivalent resistance. Okay, let's start from the first let's call this R1 prime, this R2 prime, R3 prime, R4 prime, fifth, and we need these resistances to calculate the currents. Let's call this one R1 prime, R7 plus R8 plus R9. This is 10 plus 4 plus 10, 24 ohms. R2 prime is equal to R1 prime in parallel with R6 equal to R1 prime times R6 over R1 prime plus R6, and it will give us 24 times 8 over 32 will give us 6 ohms. R3 prime, it's R2 prime plus R5 plus R10, and it's 6 plus R1 plus 1, and it's 8 ohms. R4 prime is R3 prime in parallel with R4, and it's R3 prime times R4 over R3 prime plus R4, and it's 8 times 24 over 32, and it's 6 ohms. R5 prime now, 5 prime, to yes, this is R4 prime plus R3 plus R11, and this is 6 plus R3, 3 plus 3, and this is 12 ohms. R6 prime, this is R5 prime in parallel with R2, and this is R5 prime times R2 over R5 prime plus R2, and this is 12 times R2, R2 is 12 over 24, and it's half, 6 ohms. Now we calculate R7 prime, this is R6 prime, we add R1 and we add R12, this is 6 plus 1 plus 1, and will give us 8 ohms. From this we can calculate I1, this is V over the equivalent resistance, which is 8, this is 320 over 8, and it's 40 amps. From this we can calculate I3, we need I3 and I2. I3 current divider, this is R2 over R2 plus R5 prime times I1 R2. R2 is 12 over 12 plus R5 prime, 12 times 40, and it's half, 20 amps. Now we know I3 we can calculate I5 is equal to R4 over R4 plus R3 prime times the current I3. R4 is 24 over 24 plus R3 prime plus 8 times 20, and I5 will be equal to 15 amps. Knowing I5, we can calculate I8, which is equal to I7 and I9, and it's equal to R6 over R6 plus R1 prime times the current that flows here, which is this one. R6 is 8 over 8 plus R1 prime, 24 times 15, and this is equal to 3 amps. And that's it. It looks complicated, but it's not that complicated. We can use the current divider or the voltage divider to resolve this problem. And thank you very much.